Hi guys, what's up? Welcome back. In this video, we're building a Golang program to work with the Pexels API. Pexels is a free stock photo and video library. It's very similar to Unsplash. If you've used Unsplash and Pexels, they're in the same category. All right, so what you can do here is you can just search for anything, like let's say waves or something like that, and you can download all these images and all these videos for free. All right, and if you come here, you can also get your API. So you can get your API key. This is your API key, and we'll be using that. And you can also read the documentation for Pexels. But before that, let me show you why you would want to use the Pexels API. I mean, if you can just download the videos and photos, why would you want to use the Pexels API in the first place, right? So this is a very popular product called Notion. This is team collaboration software. And here, if you create a new board, you can set the covers here for every board. So if you say change cover, you see all these images which are in their gallery. These are the fixed images in their gallery. But if you don't like these images, you can always go to the Unsplash button, where you can directly search for Unsplash images directly from inside Notion. Right, so they have used Unsplash, but we could be using Pexels. So Unsplash is very similar. Let me show it to you. It's exactly the same type of an idea. You can search for images for free, but we'll be using Pexels because Pexels is a little more popular. More companies use it. So if you're building any new modern product these days, then you would ideally want to use the Pexels API because if you want to give features like, for example, the user to be able to customize anything on your product. For example, this cover board that we can see right now, the cover photo. And similarly, you could have profile pictures and avatars and all those things that you can easily access using the Pexels API. So that's what we're going to build. So now this is the documentation. You can go through the documentation if you want, but what I've done is the way I've built the video, I have created these very small simple functions. I've basically distilled all the documentation and created these small simple functions here, which basically work with the API. So you don't have to read the documentation if you don't want to, but it's always recommended that you go through the documentation and understand how I would have come to this function, and in the sense why I would have created these functions. So these basically these are all the functionalities that the Pexels API let you do. So it has search photos, it has curated photos, it has get photo by ID, it has search for videos, all of those different things it has, right? Now I'll show you a quick demo of how this API works. So if I say, so now these are all the functions that I have in my program, and then this is the func main. In the func main, we can basically create a new client with the token for Pexels, and then we can use the client to call the functions that we have created above. For example, let's call the search video function in this example right now. So I'll go to my program here. I'll say go run main.go, and it's basically going to search for waves, right? And it's going to show me some results of waves here. It's going to send me all these links basically, which I can use. All right, and so this is just one example of function, but you can also search for photos. And mind you, all these get photos, search photos, and search video I've already defined here, all these functions, and we'll build them together right now from scratch. So if you run it again, now it will basically search for photos instead of videos. So I'm showing you in this video, I'm just showing you the basic way of working with the Pexels API. I'll just be outputting the data into the terminal, but as you know, there are hundreds of videos, Golang videos on my channel, where I show you how to build APIs, how to build front end and React and all those things, right? So you can take the next step. You can actually use this logic to build an API layer. You can build like those function handlers and route handlers and all of those things. And you can then test it using Postman, in the sense the Postman calls, let's say, the search photos function with could be a post request and sends all this information in. And then a func handler function can handle this request and then basically call the Pexels API. Or you could build a React frontend, a very simple React frontend, and then you can have you can show those images also to the user, and the frontend can call the backend basically. So basically you can create your own APIs if you wanted to, but in this video I'm just showing you the core basic functionality of how you can work with the Pexels API, and then you can apply it anywhere as if you like you want. You can use it for a frontend, you can use it for creating APIs here, and just using Postman to work with these APIs. The applications are too many, right? So let's get started with the program now. So I'm back in my terminal now, and I'm just using my Windows PowerShell today. No fancy stuff. I'm not using WSL and Ubuntu or anything like that, because it's a simple program. I don't need to use Docker and all of those other things here, Docker, Redis, nothing like that. It's going to be very, very simple and straightforward. So I'm in the the place in my laptop where I usually keep my Golang projects. So here I'm going to create a new directory called Golang Pexels API. So let's cd into it. And what I'll also do is I'll just initialize this program. So I'll say go mod init github.com/akhil/ Golang Pexels API. This is the name of the project. This is how my directory is going to be initialized right now. And in go mod init basically creates a mod file, go.mod file in your project. So it says creating go.mod file. So if you ls now, you'll see this go.mod file. So this is like your package.json file if you're from a JavaScript background. And now what we can do is we can open up our project using VS Code. I'm using VS Code, you could be using anything else, not a problem. And here we'll create our main.go file. So we'll say main.go, and here I'll say package main. So three things that make up a main file are package main, and then import, and then your func main, right? These three things. So if we want to work with APIs, right, we'll have to call the API. So we'll say net/http, because the HTTP package gives the ability to Golang to make HTTP requests. We want to print out stuff to the terminal, as you just saw that I want to print out my response that I received from the API. So I'm going to use FMT because Golang doesn't have the ability to print on its own, so it needs the FMT package. Then I want to work with JSON data because what I get from the API is JSON. So I'll be using encoding/JSON package. And I obviously use the OS package. I will use the string convert package, and I'll use time. So before I start working on the func main, I'll just create two constants. One for the photo API. So for the photo API, they have given you a different link here. So it's api.pexels.com/v1. And for the video API, the link that you need to call is https api.pexels.com/videos. Now the client that I'm going to be creating, actually let me write some code in the func main, and then let me explain to you what I mean by the client. So here we'll have a variable called C, and we'll create a new client to work with our Pexels API, which will basically be based on the token. So token is, you can either directly define the token here, where token is equal to whatever you want to directly say it, but I'm going to be using the os.getEnvironment package. The reason is that probably you want to deploy it on a server right now, maybe after you work on this project, and then you would want to use an environment variable to handle it for it, maybe. So that's why I'm using it. Otherwise you can just directly say the token is equal to the token, and you can skip this extra step if you want to, but I'll say Pexels token, and here I can, instead of defining it somewhere else, I'll just define it in the program, but you can define it in your production server or whatever. So I'll set this set environment variable Pexels token, and I'll just copy and paste my token from the project. So this is my token, and now you can use the client to call any function like search photos. We have not created this function yet, but we'll just work on it right now, and then we'll ensure that this function returns a result or an error if things go wrong, and then we can print out both of those things. All right, and here we can handle the error saying that if error is there, that means error not equal to nil, then fmt.errorf search error %v. If you have never used error f function before, it's basically like printf in the sense while giving out the error, it also helps you format out the string for error. And if there are no results, so result dot page is equal to 0, fmt dot error f search result is wrong. Right, but if everything goes well, you just print out the result. Now I'm printing it out, but you can be returning it, you can resolving it to the front end or anything that you want using an API. All right, so what I've done is I've pressed Control S by mistake, so all of my other import packages have gone that I'm not using here, but it's okay, I'll get them back. I'll write them back again here. Now let's talk about the client. So here we'll say type client is struct. So this client that I get here, which the new function will return, is a struct. Struct is your own data type basically in Golang. It will have a token basically, and it will have a HTTP client. So we'll say HTTP dot client, and it will have remaining times int 32. So remaining times that it can be called. Now let's work on our new client function. So here we'll say token string. It takes a token, right? The new client function takes a token which is of type string, returns a pointer to the client, returns a client, right, which will have token, it's the HTTP client remaining times, and we'll have C is equal to HTTP dot client empty, and return ampersand client. Let's set the token now. Token is equal to token, and HC is equal to C. So we created C, which was a HTTP client, right, which now will become is equal to HC, and you know that it needs a token, so token is equal to token. So we've created a new client now. Now whatever result that we get from the API, we can't use it as is. We want, because it'll be unstructured data and it'll have a lot of different fields, but we need particular fields from it. So the way to do that in Golang is to have a struct, define your own struct, and then whatever data that comes from the JSON, then you select only those particular things based on your struct. So struct is like the defined static data type that you'll create right now, and based on that only you'll take only those data points, and only those you'll keep and you'll display in your terminal, or you'll send to the front end, or you'll store in your database. So it's quite possible that you didn't understand what I just said, so let me show it to you. So for example, I'll create something called as search result, which is of type struct, right? And then here you define all the values that you want from that data. So you'll say I want a page which is of type int 32, and then you'll say per page, then you'll say total results, how many results were returned in the search result, next page, and the photos. This is int 32, this is int 32, this is int 32, next page is string, and photos is of type photo. So photo is another struct that we'll have to define now, but this photos is a slice of the struct which is photo. All right, so I'm hoping that you already know what structs and slices are. It won't be any issues to you, it won't be any challenge if you already know what these are. So let me format this properly. All right, now we also have to tell here that with JSON, in JSON format, how it's going to look. So when we receive JSON, that value that we want to store in Golang as page with capital P, in JSON is going to appear as page with small p. And in JSON, per page is going to appear like this, per page. So these are the values coming from the API. These are the values, sorry, the JSON values are the ones that are coming from the API, and these are values, the ones here are the values that we want in our program, so which we can store to our database if we want to, or to just return to the front end. So here we'll say JSON total results JSON next page, and JSON photos. Now we have a squiggly line here. That means we'll have to work on our photo struct. So we'll say type photo struct, and the photo will have an ID. ID. Will have a width, a height. Will have a URL. We'll have a field called the photographer of the image. We'll have the URL of the photographer as well. Now these are all optional. I mean, if you don't want to keep these fields, completely okay, but I'm just showing you generally the type of fields that you might want to use. So that's why I'm showing you all of these, but these are completely optional. I mean, if you don't want to keep fields except from ID, width and height, completely understandable, you can do that. So I know that ID is going to be int 32. I know that my width is going to be int 32 as well. My height is going to be int 32, and the URL is going to be string. The photographer is going to be string. Photographer URL is going to be string, and the src is going to be something called as photo source. Photo source is another struct that we'll have to create now. In JSON, it's going to look like this. So let's say JSON ID. We'll say JSON width, JSON height, JSON URL, and JSON photographer, JSON photographer URL. Make sure you put the double inverted commas at the end. And the last one is JSON src. I'll enclose that in the quotes as well. So it's giving a squiggly line for photo source. So the next thing that we want to work on is photo source. So we'll say photo source struct, and we'll say original large 2x. So whenever you get a photo file, right, it's either an original or large 2x. If you actually use the website, this Pexels website, you'll actually understand. When you get an image, you have all these large 2x, original, all of these different sizes are there. So that's what it represents basically. And you have your medium, you have your small, you have the same image in a portrait format. You have square, landscape, and tiny. Tiny is usually used for thumbnails. So I know that this is going to be, all of these are going to be links, right? So I'll say string here as well. I'll say string. Type string, and here's the type string. Now when we receive this from the API, it's going to have this exact spelling. It's going to say original. So in our Golang project, we're going to keep it original with capital O, but the API is going to give us original with a small o. JSON large large 2x. So the reason why you have to do this, you have to create these structs, is because Golang does not understand JSON natively. It's not like JavaScript. So JSON is JavaScript object notation. So if you use Node.js type of a server, it automatically understands JSON. But here you have to parse it. You have to convert between JSON and to the format that Golang understands, which could be strings or int. That's why you create these structs. So it is a little bit of work, but you get used to it, and you get more control. If you do this, you get more control over your program, and you get less errors. So you say small, and you say JSON portrait, JSON square, JSON landscape, and JSON tiny. All right. So at least a little bit of the structs are done. We have many more structs to build, but I think for now this is okay. This is good enough. So let's work on our search photos function. So here let's say func, and if you see here it says c dot search photos. This means that search photos is not just a function, it's actually a struct method of type client, more specifically. So struct methods is a completely different concept in Golang. If you don't know about it, then I highly recommend you check it out. So if we say something like this, before the name of the function, if we say something like this, then it basically means that it's a struct method and not a function. All right, and the way to access a struct method is using the client and then dot search photos. So as you know, it takes something as query, which is string. Then we can have the per page, how many results you want per page. Sorry, here you can actually send the value, like let's say 15 or something. So, and here you'll say per page, and then you'll say which page number. So for example, here we'll say 1. All right, and then it returns, as you know, two things. One is the result, one is the error. So let's say star search result, comma error, and here we'll say fmt dot printf. So let's format our string first. To format it, I need the photo API, which I've already defined, the photo API. Plus, I'm going to be using the strings that are required to create this entire API string, query string. So I'll say search and then question mark query is equal to %s and per page is equal to %d, and again page is equal to %d, comma query, comma per page, comma page. So this entire is the URL on which the request will be made, and these things %s, %d will be substituted with these values that we are receiving in this function, which is query, per page, and page. And that's what's required to create the entire API URL string on which we'll be making the request. To make the request, we'll have to create a function called c.request do with auth get and comma URL. Now URL is this basically, so we'll capture this whole thing in something called as URL, and we'll make a request here to this, and we'll capture this in something called a response, and this function might return an error as well. And after this, we'll say defer response dot body dot close. Defer function ensures that this function will be closed when this function closes. And we'll say io_util dot read all. So we get access to the read all function from the io_util package. We're going to take our response.body and going to read the data from it. And we're going to assign that to data, or we're going to get an error from here. The data, so first let's handle the error. So if error not equal to nil, if error not equal to nil, we'll return nil from this function for the search result, and we'll return the error. Let's define a variable called result. It's of type search result. Search result, we've already defined a data type in the form of a struct for search result. So we'll say this is the result, and ideally we want to return result from this function if everything goes well. Now, how do we get the result inside search results, right? So we'll have to say data, the data that has been read from this response body. We want to be captured that inside result, but to do that we'll have to use the JSON dot unMarshal method, and if there's an error it can capture the error as well. So here we'll have to include the io/io_util package and the encoding/JSON package. Now I know I had already included these, but since I pressed Control S by Control save by mistake, so it had removed all those packages that I was not using in the program. So now there's only one error. There's only one squiggly line here, which is for the request to auth, which basically makes request to the API. All right. So actually, let's work on this function, the request to with auth function. So as you know, it says c.request to with auth. That means it is a struct method and not a simple function. So here we'll say request to with auth. It takes the method and takes the URL, which is string, right? Takes the method and the string, the URL. It returns the body, which is response or an error. So we'll say here http.response is what it returns, or error. And now we'll use the http.newRequest method. Now you have the HTTP package here, and that's what you're going to use to make a request. So we'll say new request. To make the new request, we need method, comma URL, comma nil, and we'll take a variable called request in which we'll capture this. We'll handle the error if error not equal to nil, which is this error here. If this returns an error, we're handling it. So we'll say if error not equal to nil, then we will return nil from this function and return the error, right? So for the response, we'll return nil and we'll return the error. Now, since this is making a request with the help of auth, and auth in this case being your token, so we'll have to set our header. So we'll say we'll say add authorization, comma c.token. Since it's a struct method for C, which already has access to the token, because C is a client which has token value already present, so you can easily access token using c.token. All right. And c.hdp client. So our client has something called as HC, which is the HTTP client. So that's what we are trying to access here. c.hc, which is the HTTP client, and we'll access the do method, and we'll take this request, which has basically this new request and which has a header for the authorization, and we'll call the do method in the HTTP client library, and we'll get a response here. So we'll either get a response or we'll get an error. So let's capture those values here. Again, we'll handle the error. If error not equal to nil, we'll say return response comma error, and we'll use our string convert method, response.header.get x rate limit, it's single x here, x rate limit remaining times comma error. So remaining times is what you want basically in the client. You want to set that, so that's what we're trying to get here. If again, we'll handle the error. If error not equal to nil, we'll say return response comma nil, else c dot remaining times convert into int32 and pass times in that, return response comma nil. So here we don't have the string convert package. Actually we do. Alright, so there's only one swig line here. This is sorted. So all we wanted was basically the rate limit, and that we have set in our client in the remaining times variable. So this is what basically our request do with auth function does. And now this function request do with auth is something that we'll be using in all the other functions as well. So this was only the search photos function, and now we can also work on our curated photos function. So let's create our curated photos function. So we'll say func c star client because it's of it's a struct method. So we'll say per page int curated result comma error. So the functions that I'll be covering will be curated photos, get photo, get random photo, search video, popular video, and get random video. That's about it. There are many more functions that can be covered with the Pexels API, but I'm covering the bare minimum, as in the at least the functions that you need. Like for example, we covered the search photos here. We'll cover the search videos also. Right now we're covering the curated photos, but there are so many more functions that can be covered. But I'm showing you the bare minimum functions that are important in Pexels, but you can create more functions by reading their documentation. All right. So here we'll say fmt.sprintf again, and we'll use again the photo API /curated % per page equal to %d, and %page is equal to %d, comma per page comma page. All right, so we'll again make a request to our request do with auth method. So we'll say request do with auth get comma URL, and here we'll say response comma error. If error not equal to nil, return nil comma error, and we'll say defer response dot body dot close util dot read all response dot body and we'll capture that in data comma err. So we'll say if error not equal to nil, return nil comma error, and let's create a variable called result, which is of type curated result. So curated result is another struct that we'll have to create right now. All right, and here we'll say data comma ampersand result, sorry, and we'll capture the error, and we'll use the json.unmarshal function to take the result and to take the data, sorry, and create it according to result, right, which is of type curated result, which we'll have to define now. And what we return from this function is result comma error. So now let's work on our curated result struct. So here we'll say type curated result, just type struct. It has page, which is capital P. It has per page, next page, and photos. Int 32 int 32 type again. This is of type string, and this is of type photo, which we have already defined here, which is another struct. So let's format it out, and now we'll have to define the JSON counterpart. So we'll say JSON page JSON per page JSON next page and JSON photos. Perfect. So we have two fully functioning functions ready. There's a spelling mistake I see here with tiny. I'll just correct it. Yeah, so two fully functioning functions that we have are, one is search photos and the other is curated photos. And then both of these functions call this function called request do with auth. So that's also ready. So far everything is looking great. And now we can start working on our get photo by ID function and get random photo. So these are two really simple and straightforward methods. So it might happen that you might know the ID of a photo and you want to get that photo from the API, the Pexels API. So in that scenario, we'll use the get photo function. Again, it's not a function, it's a struct method. So we'll say get photo, and it takes an ID int 32. It returns just photo comma error. By photo we mean this photo struct that we've already defined. It just returns the photo, that's it. And again, the same format, we'll use printf to create the link. So let's say fmt.printf, we'll say photo API plus /photos /%d comma ID, and we'll capture this inside URL. There are, I think, double brackets by mistake. I have to remove those. So now we have the URL with the formatted string, and the same thing. Now we want to call the request do with auth method that we've already defined here. We want to pass get, and we want to pass the URL. All right, so this API is pretty straightforward. It's just photo API, which is photo API is defined here, apipexels.com/v1 and /photos/ the ID. So it just replaces the ID here, and this is the URL on which we can make the request using the request do with auth method. And we get a response, error. Let's handle the error. If error not equal to nil, we'll return nil, error. And we'll again use the defer function, response.body.close, and again we'll use io_util.read all to read the body. Again, by mistake there are double brackets. Let's remove those, and let's capture this value in a variable called data, and let's capture the error as well. So let's create a variable called result, which will be of type photo. Photo is a data struct that we have already defined here, and that's what we'll be returning from this function. Now we'll do our unmarshalling. So we'll say json.unmarshal, we'll say data, ampersand result, and we'll capture this error if an error is returned from here. And we ideally want to return the result, error. We want to return the result if there's no issues, basically, ideally. That's what we want. So this is the entire get photo by ID function. And now, so yeah, I can see an issue here. Here we should have said error, not err. Now, as you can see, there are no runtime errors, at least here, or syntactical errors at least. So we have our get photo by ID function covered, and the other one that we wanted to work on was get random photo. So to get random photo, we'll have to create a random number, and to create a random number we'll have to use the time package and the math/random package. So let's start creating our function. So we'll say function C star client, because it's a struct method, and we'll say get random photo. It doesn't take anything, it doesn't take any parameters, this function, but it does return a photo, or it returns an error. So we'll say random.seed time.now.unix. So the time package, we don't have the time package, and we don't even have the random math/random package, but don't worry about it. Let's create a random number. So we'll say rand.intn 1001. So result, error, c.curated photos 1, random number. So we are going to call our curated photos function, and between 1 and the random number, sorry, this is, so the random number basically will be the ID of the image that we need. So we'll say error, if error is equal to nil, ampersand rent.result.photos is equal to 1. Then we'll return ampersand result.photos 0, nil. I'll return nil, error. So we have squiggly lines for random and time. So if error is nil and length of result.photos is equal to 1, that means there's some result that we got, then we're just going to return result.photos. And let's include our math/random and math/random and our time package, so that all the errors go away. So we have access to our getRandom function as well, getRandom photo function as well. And now we'll work on our search video function, our popular video function, and our getRandom video function. And then our project will be completed. So let's start writing down the functions that we'll be needing here. The first one will be called search video. Then you'll have your popular video and your get random video function. So it will obviously accept some parameters, return a couple of parameters. It'll have a definition. It'll be a struct method, so we'll have to say C and asterisk client. And the get random video function returns a video. Now video is a struct like photo, but we have not defined it. There'll be some different some values that will be different in the video struct, so we'll define it in a while. Then your search video function, it's again a struct method, so we'll say C and asterisk client. It accepts a couple of parameters, returns some, and it has a function definition. The search video will accept query per page, how many results you want, and on which page do you want to get, and then it returns video search result comma error. So just like for search photos we had search result, we'll have a video search result as well for this function. And now the popular video function, again we'll say func C star client, accepts a couple of parameters, returns some, and has a function definition. It's going to accept per page, it's going to accept page of type integer. It's going to return popular videos, which is a completely different data type. So we have video, popular videos, and video search result. All of these are different data types. And it also returns an error in some cases. So what we'll do now is we'll start creating these structs. So the first struct we'll have is video search result. Then we'll have something called as video. And we'll also have a struct called video files and video pictures, and then we'll have popular videos. So first let's create the popular videos one. So we'll say popular videos struct. So here video search result, popular videos, and video, all of the three squiggly lines here have gone away because we have defined these structs. And like I said, there are two more. One is video files and video pictures, so we'll write them down as well. Video files and video pictures. So let's start working on these one by one. For the video search result, we'll have page, and we'll have per page, we'll have total results, we'll have next page, and we'll have videos. Page will be of type int32, per page will be of type int32, total results will be integer as well, next page will be string, and videos will be a slice of type video, which we'll be defining soon. Now we'll have to define the JSON versions of these. So from the API we'll receive page, we'll receive per underscore page, we'll receive total results here, and here we'll receive next page, and here we'll receive the videos. Now let's work on our video struct, the video details struct. Actually, it will have ID, so the videos, it's almost like the photo one that we created, right? So it'll have an ID, it'll have width, it'll have a height, it'll have a URL, right? Very similar to the photo one, right? ID, width, height, URL. It'll have an image, a representational image. When we show the video, we don't actually show the video, we show an image from the video, right? And the link for the full res file, and duration, video files, and video pictures. All right. Now video files and video pictures are already two different structs that we'll create in some time. So ID I know is int32, width and height also I know are int32 and int32 respectively. The URL is a string, image is a string, full res is an interface, duration is float64, and video files is a slice of type video files, which is going to be a struct that we'll define soon, and video pictures is again going to be a slice of type video pictures, which is a struct. And here we'll start defining our JSON versions of the same. For this it will be ID, for this it will be width, for this it will be height, URL for this one, image, full res, sorry, there's no capital R, only small r, full res, and then you have duration, video files, and video pictures. Okay, now we have 3 more structs left to be defined. So the video files one, Actually, let's work on the popular videos one before. So for the popular videos one, you will have a page. You will have per page. You'll have total, results, URL, and videos. This is N32 and 32 again. Total results are also N32. The URL is a string and videos is a slice of type video that we have already defined. And now let's start defining the JSON versions of all of these. So here it will be page, here it will be per page, total results, URL, and videos. All right, now let's work on our video files and video pictures. So in the video files, you'll receive an ID, you'll receive the quality of the video file, you'll receive the file type, what type of file it is, which can be the format also. Then you have the width, the height, and the link of the video. So it's int32, quality is string, file type is string, height and width are int32 and int32 respectively. Link is string. Here we'll say JSON ID, JSON quality, file type, width, JSON height, and link. So these are the values that you'll receive from the API, and these are the ones that we want to keep for our Golang program, and these are the types in Golang. Right, so we have created our video file struct. Now we want to work on the video pictures, which is quite straightforward. Just has ID, just has ID, just has a picture. It has a number. The ID will obviously be int32, picture will be string, and number will be int32 as well. Here we'll say JSON ID, picture, and R. So all of our structs are complete, and now we'll start working on our functions, our search video function, and our popular video function, and our get random video function. And then we also have one function for getting the remaining requests in this month, which we'll use here somewhere, and then we'll define it as well. So let's work on our search video function. So search video, Search video is going to be very similar to search photo function, where you have this sprintf to create the string, the URL to which you will make the request, and then we'll use the request do with auth method to make the request, the get request to the URL, and we'll get that in the response. So quite similar, right? So let's get started. So we'll say fmt.sprintf, and here we'll say the video API. So video API was the other string that we had defined here along with the photo API. So the video API plus slash search query %s ampersand per page %d ampersand page to %d query per page and page. Here we'll equate that to the URL. So we'll use the c.request do with auth function. We'll use the get method, and by mistake we again have these double brackets that I have to get rid of now. So we'll get a response and an error. Let's handle the error. If error not equal to nil, we'll say return nil comma error, and we'll again use defer response dot body dot close, and we'll again have to read from our response. So we'll say ioutil dot read all response dot body data comma error, and if there's an error, if error not equal to nil, that means we'll return nil comma error. We'll have var result video search results. So we create a variable called result. It'll be of type video search result. So video search result is the struct that we've already created, and this is what we want to ideally return from this function. Right now, to get the values that we have in data to be based on the result struct that we need, as you already know, we need the JSON.unmarshal function for that. So we'll say data comma ampersand result, and if there's an error, we'll just capture it here, and we'll return ampersand result comma error. So we can see two errors here and two squiggly lines because we have not defined these two functions. So let's start working on these functions. So here we'll say in the popular video function, we'll again follow the same methodology where we'll have our sprintf, we'll make a request, we'll read from the response, we'll create a variable called result, and we'll unmarshal the data. All right, so quite straightforward, as in it's going to be almost similar. So we'll say fmt.sprintf and video API. Actually, along with these two functions, we can also create another function to help us find out how many requests we have left. So we'll say get remaining requests in this month, and just returns in 32, and all this function does is return .c remaining times. All right, in case you want to access it from the func main, you can just call this function. It just sends you how many times this month you can call the API more. Okay, So here by mistake again I have double brackets here, so we'll say fmt.sprintf video API plus slash popular question mark per page %d and page is equal to %d again, and here we'll say per page comma page, and we'll catch this in a variable called URL, and we'll call the function request to with auth. We'll call the get API and comma the URL. We'll capture that in our response and error. We'll handle the error, so if error not equal to nil, we'll return nil comma error, and we'll use defer again for response dot body dot close. Then we'll again call the util function, so util dot read all is what we need, and here we'll pass response dot body all the data we need in a variable called data, and if there's an error it can be handled with error. We can handle the error now. If error not equal to nil, we'll return nil comma error, and we'll create a variable called result which will be of type popular videos, popular videos being a struct that we've already defined. And ideally we want to return the result and error. So here we'll say error is equal to json dot unmarshal data comma ampersand result. So the popular video function is done. Now comes our last function, get random video, and then we'll start testing our program, and then there could be errors that we'll need to solve. So this is going to be very similar to the get random image or the get random photo function. We're going to use the random math/random package time.now.unix, and we'll say random.intn random number. Now we'll see dot popular video 1 comma random number, and we'll capture that in a variable called result or error. So if there's no error and the length of result dot videos, that means there is some result is equal to 1, then we are going to return result dot videos 0 comma nil, and at the end we're just going to return nil comma error if there's an error. All right, so that was our entire program. It's about 250 lines, which is not huge. It's a small size program, and what we'll do is we'll now try running the program. So we'll go back to our terminal and we'll say go run main.go. So we don't have any errors, as you can see, and we're getting all the images here, and here we can also search for video. So now it's giving a squiggly line because for search video I have not said string here, and now everything looks all right. So let's go run main.go, and there seems to be some error, in the sense it's not working. So let's try and inspect why it's not working. So one issue that I think could be is that here with search video, I'm not using a slash here, which is wrong obviously. So it's not creating the perfect URL for me. And I don't see any other issues as of now. So let's try running this program and see if there are any more issues. So we'll say go run main.go. So we're getting all the results as expected. So that means there are no issues with search videos function as well. Now let's try running the get random photo function. So it doesn't take any parameters, and we'll say get random photo. Let's see if it works now. So here there seems to be some issue. Okay, if you're using this, then you can't be using this obviously. Let's try running it now. So it has got random photo for you. Now let's get random video. Let's see if the name of the function is, yeah, it's get random video. So let's get random video. Works perfectly. So most of the functions here, like all the functions basically are working. Now the get random photo and video, you might be wondering why, where could it be used, right? So let's say if you add an icon here in Notion, it creates a random icon for you. So something like this, if you're building a functionality like this could be, a get random photo, get random video. So that's where Pexels can help you a lot. All right. So we've done quite a bit. We have done, search photos, search videos, get photo. If you have the ID, you can also get photo. You can get random photo. You can get random video. Get popular videos as well. So it's quite, it's quite handy if you want to build a functionality like I showed you in Notion. And there can be so many more applications of this, right? So in the coming videos, I'll also be taking you through the Trello API, the Notion API, Stripe API. And I have, I think, many more planned. I think Asana. I've already done the Slack API, right? So I've already done the Wolfram API as well. I've done the Wit AI API as well. So yeah, so the upcoming ones will be Trello, Notion, Asana, and let's see which ones. But at least these ones will be coming up soon. So thanks a lot for watching. Do stay subscribed to this channel because we have hundreds of videos on Golang, and almost every day we're coming up with a new video. And thanks a lot for watching, and see you in the next episode.